Hi, my name is Alessandro Gangelosi and that's a video tutorial coming from cgcookie.com for MaxCookie. This time we'll introduce another interesting topic related to particles, and we'll see how to make a simple setup to control sparks animation. So let's set first of all the resolution, the unit setup, and we have centimeters and the system unit setup set to centimeters, so it's perfect. And let's imagine that we have maybe some objects that will collide over another mesh and will create some sparks. So let's imagine that we have, first of all, a ground, and this will be the ground. Let's call it ground. Okay. And that's, let's say, 3 meters by 3 meters. Then we have let's imagine a table. Okay, and the table will be 1 meters 20 by let's say 60 centimeters, and its d8 is 3 centimeters, maybe 4. Okay, and this one is let's go there to have a tape. Let's say maybe there. Okay. At 60 centimeters we have the plane, so let's imagine that the plane is there. Let's zoom a little bit. We can remove the grid using the G key there. I like to change the color of this mesh because it's not so visible inside the viewport. And let's remove the grid also there and also there. Okay, we have hold the mesh in the right position. Let's imagine that we have our plane there. So another thing we have to do is to imagine that we have, for example, there an object. Let's imagine that we have, for example, a cylinder or a tube. And this tube will be something like an object to work with. And we change a little bit the 8. And we rotate it using the angle snap, and we can rotate by 90 degrees, and we set it there. And let's imagine that this object is a working object. It can be a working object where someone is working with some tools. Then we have, let's imagine another object that will be maybe some instruments, and it will be a cylinder that will be something like a working tire, you see, and we have it there. And this one will rotate, and to see it rotating we can go there and we can set a material, and I'm moving the material there, and this one can have a checker, and we have them up there. And let's imagine that we have the, let's go there to have a VME double map. So you see we can have the rotation there, it will be visible. So let's go there and let's set more frames there. So let's say, for example, 300, just to have enough. Then we try to create a really simple animation. So let's create something like that. It will be maybe the body part that will move this tire, move, and we have it near, and then we change the pivot and we move it there. Okay, and then we make a copy, so we have our basic tool. Okay, it's really simple. Now I'd like to create a dummy just to control all the stuff there. Okay, we can center, and then I can move it there. So now let's scale a little bit this dummy. Then we link this one to there, and this one to the dummy. Let's see what happens. If we move this one, you see that we have the animation, and if we rotate this one, we have the rotation. Okay, we have also the possibility to rotate this one, so we can have an animation there. So let's do something really simple about the rotation. We have the rotation over the y-axis, and we can control it with a float list, so we'll be able to use the Bezier and also another controller. And in the variable we can set another controller, and we'll use an expression. We'll make a really simple expression, so float expression. We have the window there, and we'll say that we have the 0 plus f, so we'll use the frame number, multiply it by, let's see, 5 just to make a test, and we close in this way, evaluate, close, and you see it is rotating. So it continues to rotate. But we can also have a slower rotation, and to have a slower rotation, right mouse button over the float expression, and then you can change the multiply. So we can use, for example, 1, close, and you see that the rotation is a little bit slower. But it's just to make a simple animation, so it's not so important. So now we can have the basic animation. Let's imagine that we have this one there and there. Okay, then animate. You see we have the animation, and we move it there, and then at 60 we have the animation. Let's remove okay, so you see it is moving, and then it starts to go down, and then it is rotating, and then we can have, for example, until 140 this animation. Let's set keys there, and then we say that we'll set up there and there. It is move it back. So that's the animation. Work over there, and then it is over. So it's really simple, nothing so special. Let's save the scene before we have maybe some crash or something like that in the right folder. Okay, let's create a new folder, 3ds Max tooth. This will be particles, and this will be playing with sparks. Okay, so 3ds Max, particles, playing with sparks. This time we'll use particle flow just to be really fast, but obviously you can use also thinking particles if you need it. So we have the basic scene there. You see, it's real simple. And then we can start to play with the particles. So let's go there. Let's scale a little bit. I add a skylight just to have a better illumination inside the scene. You see, so it's better illuminated. Okay, something like that. Perfect. And now we can go there and let's start creating a particle flow source. This will be our sparks. Let's open particle view. Let's try to have more space. Okay, so we don't need rotation for the moment, so we can remove it, right mouse button and then delete. And we don't need the position icon, but we need a position objects. So we'll go there and we'll use a position object, and then we select it and we add the rotating mesh. So we have the particles at the beginning, so let's say 0 and 0, and you see that the particles now are moving, so we have to remove the speed, right mouse button and delete. So you see the particle stays there, and we have to say to the particles to lock on a meter. So we have the particles rotating with the rotating objects. Perfect. We'll use these particles to create the sparks, and it will be a really simple trick, because we'll say that we'll have sparks when these particles are colliding to the mesh. So what we need first of all is a collision, and the collision can be done using if you have no Krakatoa, you have to go there inside the forces and you have to use deflectors, and we can use a universal deflector. That's safe. This universal deflector will be based on the tube. Then we have to go inside particle flow, and we have to say that we have a collision. In reality we have a collision spawn. So we have there a collision spawn event, and the collision spawn, select by list, we can set the universal deflector. So let's see what happened. Actually it's not colliding. So we have, let's move this one just a little bit up. Okay, so we have for sure collision. Go there, and we say to this one that when we have the collision, let's move the output there. And connect to the display. When we have the collision, we have a visualization as circle. So let's see what happened. And you see that we have the collision. Perfect. Okay, so the other way, if you have Krakatoa, is to use the Krakatoa collision. So turn off this one. Let's imagine that we have everyone Krakatoa collision installed, and you can use Krakatoa collision there, and this one will be connected there. The Krakatoa collision needs to set the node. The node will be the tube. So let's see what happened. You see that we have the collision. So the main issue is that the Krakatoa collision, you know, is really faster than the collision spawn. But in this scene it's really simple, so we can set to off this one, and you know that we'll use the collision spawn or the Krakatoa collision. The main difference is that if we use the collision spawn, you see that the start particles still go there, and you see that we have the spawning, the creation of new particles. So for example, if I say that these particles are not visible and the most important thing is also that you have to set the shape to 0, so we'll have not shape at the beginning. You see that we have then there the particles created by the collision spawn. If we have this one set to on and the collision spawn set to off, you see that we have the previous particles going away and we have no spawning. So there are two different ways. It's not so simple to see it there, but you can be sure that we have the spawning there, so we have more particles, and we have no spawning there. So if you want to have more particles, you have to use the spawning. Okay, let's set to off. I leave this one there so you know that you can use the Krakatoa collision or the collision spawn. Save and go back there and set to on. Okay, then let's select the particle flow source, and let's say that we see 100% particles inside the viewport. Perfect, so we have all the particles. Then let's see the collision there. We can also imagine to have, maybe if we need also just the collision and then the spawning, so it depends on what you want to have. Actually we have the spawning and the delete of the particles. If we have no delete, we'll have, you see, more particles, because we have the particles that stay on the tire that are colliding, and we have also the spawned particles moving. So let's delete. Okay, and we have the right one there. We have the spawnable set to 100%, and we can start to have lines. So it is more simple to see that we are talking about something similar to sparks, because it is similar because we are using lines, and the lines are bigger or shorter depending on the speed. The other thing we have to do is to have some gravity, and actually we have no gravity inside the scene. So let's go there and let's say gravity. Then we can go back inside particle flow source, and we have to add the force, and we can go there and set the force by list and select the gravity. Let's see what happened, and you see that we have this one launched by the force, and then we have them falling down. What I like to do is that if we have collision with the meshes, we have spawning. So to have something like that, we can use again some universal deflector, or we can use the Krakatoa collision. This time I use the Krakatoa collision because it's faster. So let's go back there, and let's say that we have a Krakatoa collision for the particles there. So the first test is with the tube, and the second test we have no animation for the mesh, and the other test will be with the table, and the other test will be with the plane. Let's see what happened. You see that we have particles falling down and bouncing, but I like also to have spawning when we have this kind of effects. So first of all, let's change a little bit the magnitude, so let's say 35%. We'll have some variation. Let's imagine 35% of variation and 30% of chaos, so 35, 35 and 30. Let's do the same there, so 35, 35 and 30, and the same to this one, so 35 35 and 30. Let's see what happened. We'll have something more chaotic, you see, but we have less bouncing. Just to have something interesting, we can move a little bit the plane there. So we'll have more spawning, and maybe we can have also the ground there. Okay, so you see the animation is more precise. Perfect. Now you see that we have no more spawning after a while because the particles is set to use some particles. We have just 200 particles, and when all the particles are colliding, you have no more collision. So we can say to have 300 and let's say 2000. So we'll have particles continue to be emitted, you see, from the mesh, and will be more precise. Okay, then we can set also the dust of the particles. So let's imagine that after a while, and first of all, I'd like to move this one there, and then I like to have some spawning there, so we can use the spawn effects. So we have to connect this one, and this one. So the particles will collide, you see, and are spawning, but the spawning must be again must work with the collision and the gravity. So I should have again this one, so copy with the right mouse button and paste as instanced, and you see that we have collision, and then we have the particles falling, and we have this kind of effects. Let's use the lines to have a better visualization. So we have particles, and you see then we have them falling down. Okay, so we don't need to use the depth, but if you like, you can have there a delete event, and we can say, for example, to have a delete after 50 frames. So when the particles has 50 frames life, will die. Another thing I like to do is to go there, and let's go, first of all, save. Let's use the universal deflector. You see that's the bounces, and we have no variation. So let's say 35% of variation for the bouncing, and let's have a chaos of 30% for the moment, and let's see what happens. Let's have more, and let's have more chaos, 70%, and a little bit of friction, 25%. You see that if we have the friction, the particles have less force to be launched. We can have less friction, or we can have more bouncing to see more bouncing with the particles. So you see that are moving in all direction. Okay, go back there. Let's see the violet particles, which are this one. So you see particles falling, and it seems not bad. Maybe we can have a little bit more force there in the spawning. So in the spawning we can have 2 spawning. Let's see what happens. You see we have more particles. Maybe we can have 3 with a variation of 35%. And we say that the 65% can have spawning. So not all the particles falling down and colliding with the ground have spawning. And we say that the speed is 100%, maybe we can have 75%, and we have a variation of 35% in speed. Let's see how it looks. Okay, you see it's a little bit. Okay, I'm checking the result, and I like to have a collision with the ground again. So let's say this one, copy and paste there, and we can connect the spawned particles. So the particles colliding create the the sparks. Sorry, the particles going to the ground, then are falling, and spawned one will have again the force. So let's see what happened colliding. Okay, and we can have there the collision, but we can have also maybe more collision, and then we can stop it. So we can have maybe more collision. Let's see what happened. Okay, and let's try to have speed set to 0, just to make a test. Okay, so you see that after a while we have the particles there over the ground, and we can have still some lines. So let's see. Obviously the lines are not visible, we can use the dots. Okay, and we can have a delete also for this one, so copy and paste. And you see that after a while it will disappear. So close and save. Let's see what happened more in depth. We have the collision. The sparks are created. The particles are falling down and colliding with the meshes, and then collide with the ground. We have some particles going through inside this one and this one, so we should go there, and we should have there more collision. Let's say maybe 5 just to start, and 5. That will be a little bit more precise. Obviously you can have better parameters to have more precise value. I'd like to have just a little bit more speed when we have the first bouncing, and the first bouncing is there. Let's try with 2. Let's see how it looks. Maybe it's a little bit too much, so let's go to 1.65. Okay, it is a little bit better. Okay, so save. So we have the basic setup, and the last thing we can see is in a really fast way how we can render these stuffs. Let's go inside particle view, and we have not set the particles, so we have to set the shape there inside the event number 2. So let's select the shape, put it there, and we'll use the tetra, and let's say that we like to see the geometry. You see we have the geometry there and are really big. We have to scale it, but we need also to change the rotation. So rotation, and the rotation will be a speed space follow, so it will be based on the rotation, as you see. Okay, Let's say that we like to see geometry also there, and geometry also there, and geometry also there, just to have a rough idea. So we have it there, and you see that we have again need to have the right rotation. So we can go there, select the rotation from the event number 2, copy, and we'll have that there as past instance and past instance. So we have collision and the particles are rotating in the right way. Okay, then the particles must be little, so let's go there for the scale, and let's imagine to have maybe something like that. Okay, then we need a material, so we'll have to create a simple shader there. We can have a really simple shader. You can tune it when you need it. Let's say self-illuminated. Go back there, and we need a material static, and we can put it there, and the material is this one as an instance. So if I go there, save, and render the scene, we are using mental array. Okay, and render, we'll have, you see, this kind of stuffs. So it's a really simple scene, and you see just point. But if we go there inside renderer, and we'll say we like to use the motion blur and render again, you see that the points are changing based on the animation. So it's a better way to illuminate, to animate the sparks. And you can also imagine that we have the possibility there to set on the glare, and we can have the glaring for the rendering. So we can render this one, and we can have the glaring, but it's not so illuminated. So let's go there, and let's say that this one is lower, something like that, and we have an area omni there, and the light will stay there. Let's imagine that it's the lamp, and let's imagine that we have a sphere and a lamp of maybe 5 centimeters. Let's see what we have inside rendering. We can have a lower value for the sky. You see that now we have the glare there. So we need to have, first of all, a lower value for the skylight, and then we have to work with a darker color there, and we can use maybe an Arcan design, no reflectivity, and we can use a bitmap, a really simple bitmap coming from Autodesk, so programs, Autodesk 3ds Max, and let's go there, maps, and we can use the arc maps, and let's see, to use something for the ground, nothing so special. Maybe we can use also simple concrete from there. So let's see, maybe the asphalt can be good enough, and we can assign it. Let's remove the blurring, and let's have, for example, tree tiling. And tree tiling, it's a really rough render, so I'm not interested to the quality. It is obviously a little bit slower there because the anti-alias is trying to have the right anti-alias of all the detail we have there. But I'm still more interested to see if the glare is picking the right pixels there. Let's have a little bit of patience. It's not so much. So we can do two things. We can, first of all, you can, for example, set it in the right way using a composing software, and this will be a really simple way. And we can use this one also with self-illuminated objects created using the Arcan design. That will be useful also to create illumination coming from the sparks. And if we like to be more precise, we can have a show save frame there. We can go near, and we can render from this point of view. We can have also a better motion blur, because you see we have a little bit of grain and the sparks are also a little bit too big. Obviously the rendering parameters are really low. Actually, you see we have nothing so good in quality. We have still no glaring, so you can set it from the outside, or you can go first of all, I like to change the scale there for the particles, particle flow source, and let's go in the right shape there, and let's say maybe 1 centimeter. So we have little stuffs, and we need a little bit more precision there. So let's say 2 for the motion segments and 10 for the time samples. Then you can select this one and copy inside the material editor to change the value, so you can merge it there as an instance. And let's go for a quality of 3 and an higher resolution, let's say 1000. Then open there, and let's say I like to render this area. You see that now the sparks are a little bit more little than before, and the motion blur is a little bit more precise. We'll see if the glare will intercept. We have some glaring, but the glare now is acting there over this highlight. So you can do it rendering on a separate path the sparks, and you can make the glow over the combustion software or other component software. We'll make maybe we can prepare a tip tutorial to see how to work with it. So I think that for a basic Spark setup, that's all. Is not so complex as you see, and we done a good job using not so much trouble to simulate it. So it was a simple tutorial. You have a basic way to create sparks, and you can make obviously different setup, and we'll see in a future tip tutorial how to set the rendering to have good quality sparks in rendering. So for the moment that's all, and I hope to see you back on MaxCookie to check for new tutorial coming from cjcookie.com. Bye.